Okay, let's work on one more of Dfa. So number 5, consider the following Dfa, deterministic finite automata, in the language of 0, 1, whatever combination it is. So for example, this time the Dfa is given. We just want to see what kind of string accept. We can just try a couple of them. We figure out. How about 0? It will work because you have a 0, it goes to here. Okay, so 0 works. How about 1? Okay, it doesn't accept because if you go 1, 1 goes to here. So that's dead, right? So it doesn't accept. And then we just say followed binary counting. 1, 0. Does it work? So 1, and if you go 0, so 1 goes here, and 0 go back to 0, dead. So that end up here. Once you have to end up with one of the final state, it works. So final states is denoted with double circle. In this diagram, B and C are the final states. So 1, 0 doesn't accept. Okay, how about 1, 1? Okay, and how about 1, 1? So then 1 and 1, so it doesn't accept. How about 0, 1? And that works. So 0 and 1. That goes through this state. And whatever you do, follow a 1, so then that works. And 0, 1, 1. You see? So 0, 1, 1, you go 0, 1, and then 1. Still stay in the final state. That works. So then, how about 0? In fact, 0, 1, 1, 1, 1. Whatever, no matter how many 1s followed here will stay. So anything that's 0 and followed a number of 1s is all okay. Because once you have 0, 1 to start, and whatever number of 1s is going to be here. But as long as you have 1, 0, will be dead. For example, 0, 1, 1, 1, 1, 0, 1. And then what happens is you go here, 0, 1, that goes to the final. Okay, and then you have 1 stay in the final, 1 stays in the final, 1 stays in the final, and 0 all of a sudden you go, So no matter how many 1s over here, it will stay here. And then you have a 0 and go to this state. Once you get to this state, it's trapped in this state. Normally, if you have a trap or dead state, as long as it's not the final state, that's not trapping, you consider it a reject. Okay, if the rule is, some of you still didn't get the rule. The rule is, if the string end up in the final state, it accepts. If the string run out, end up with non-final state, it rejects. Alright, hope this makes sense. So after all, what this is, so this actually accept start with 0 and followed by 1 or many 1s, or this kind of string it accept. No zeros. Okay, no zeros follow. So 1, 0, 1, 0, and goes to this type of string. So the automation is a machine to say, well, to recognize a set of strings. So actually, an automation, you think about it, it's a kind of a language. And all the strings that accept is one kind of is form a language or a set of strings. And well, next question is simply is another one. So you follow this idea, play with this. It accepts 0, 0, 1, and 1. So play with next one. So that's the idea of this one. So 1 accept. So 1 it accept, and 0, 1 accept. So 1 okay, 0, 1 okay, and 0 okay too, because 0 it goes to 0, okay too. Anything else? So how about 1, 1? No, because 1, 1 goes to data state. Okay, so 1, 1, 1 go to data states. Okay, it only accepts 3, so that's this one. Hopefully that illustrates the idea. Hope you do better in a later quiz or assignment. Bye bye for now.